Today we are going to discuss about performance of a computer. What do you mean by performance? Performance is nothing but the speed of the computer, how quickly it can execute the programs. The speed is affected by the design of its hardware and its machine language instruction. To increase the performance, that is to provide the best performance, we have to design the compiler, machine instruction set and the hardware in a coordinated way. The measurement of performance of an entire system is known as elapsed time, and it is affected by the speed of the processor, the disk and the printer. Similarly, we have a processor time which is the sum of the periods of processor which is active, and it is depending on hardware involved in execution of individual machine instructions. Performance is depending on various parameters. Some of those parameters which we have to consider are processor clock, basic performance equation, pipelining and superscalar operation, clock rate, instruction set, compiler. After doing all these improvements, we have to measure the performance, and we go with performance measurement equation which is provided by spec. Okay, coming to processor clock. Clock is nothing but a timing signal which is controlled by processor circuits. The clock defines a regular time interval called clock cycles. The processor divides the action to be performed into basic steps. Each basic step should be completed within one clock cycle, such that we have to design an instruction. And there comes another important parameter, length P, which affects the processor performance, where the length should be less so that the clock rate R can be increased, which in turn increases the performance of a computer. In standard electrical engineering terminology, cycles per second is termed as hertz. Million is denoted by the prefix meha m, and billion is denoted by the prefix giga g. For example, 500 million cycles per second is abbreviated as 500 megahertz, and similarly 1250 million cycles per second is abbreviated as 1.25 gigahertz. Next comes basic performance equation. Basic performance equation is nothing but T equal to N into S by R, where T is the processor time, N is number of instructions, S is basic steps within one particular instruction, and R is the clock rate. So our goal is to increase the number of clock rate and decrease the number of instructions and basic steps in one instruction, which in turn increases the performance of the computer by decreasing the processor time. So to reduce the number of instructions, we have to write a source program in such a way, and to reduce the basic steps in an instruction, we have to overlap the instructions, and to increase the clock rate, we have to use higher frequency clock, which altogether in turn reduces the processor time. Next comes pipelining and superscalar operation. Pipelining is nothing but multiple independent instructions are executed parallelly, and executing multiple pipelines parallelly is known as superscalar operation. This increases the performance of a computer. Then comes the clock rate. We have already seen that clock rate should be increased. So to increase the clock rate, we are going with two ideas. One is improving the integrated circuit, and second thing is reducing the amount of processing done in one basic step. Next comes instruction set. Instruction sets are two types. One is complex instruction set computer and reduced instruction set computer, that is CISC and RISC. The key difference between RISC and CISC is number of computing cycles. So the difference is based on the complexity and goal of their instructions. Here are a few differences between RISC and CISC. The first thing is RISC CPU design strategy is based on simple instruction and fast performance, and CISC design strategy is based on single instruction which is capable of performing multiple step operations, that is complex operations. Second difference is most of the instructions in RISC are completed within one machine cycle, and in CISC most of the instructions are completed within 2 to 10 machine cycles because it is complex instructions. And the third thing is pipelining is very easy to execute in RISC machines because the basic instructions are simple, and in complex instruction set computer, pipelining is not implemented easily because the instructions are complex and independent or dependent on each other. Next comes compiler. Compiler is a software that translates a high-level language into machine understandable form. So we have a optimizing compiler which increases the clock rate and reduces the number of instructions and basic steps within an instruction. So reducing number of instructions and basic steps within an instruction can increase the performance. The compiler are capable of rearranging the program instructions to achieve better performance. The ultimate objective is to reduce the total number of clock cycles needed to perform a required programming task. So, the compiler and the processor are often designed at the same time with much interaction between the designers. Performance measurement. So far we have discussed how a performance can be increased using various parameters. Now, after increasing all these things, we should able to measure the performance which we have achieved. So, to measure the performance, a company called System Performance Evaluation Corporation. It's a non-profit organization. It selects and publishes some application programs and its results, so that using this particular equation we can measure the reference computer and the computer under the test. So this is the equation for measuring the computer rating. Spec rating is equal to running time on the reference computer by running time on the computer under test. And another equation is spec rating equal to pi I equal to 1 to n spec I overall 1 by n, where n is number of programs in the suite. So using this particular equation we can measure the computer which we have designed. Thank you.